Hi guys, this is Coach Ideal from Math Academy, and welcome to our lecture again. And today's lecture will be on factorization of quadratic equations. I believe this is covered in secondary 2. So let's see how this factorization is done. Yeah. So unlike the previous factorization question, this expression doesn't have a common term for all the three terms available. Like you see here, x squared, 4x, and a 3. There are no common terms for all these three terms. So there is a special method to factorize this. But first, let's see what are the features of a quadratic equations. It will help you to spot or recognize that it is a quadratic equation. The first thing is it has an x with the power of 2. Okay, or in other words, the highest you have an x squared term. It can be 1, it can be 4, it can be 3x squared or something, as long as the power of x is 2. And there is one term with just x and another term just a number. Okay, so the special method to factorize this is by using the big cross method, or some students or some teachers call it the cross factorization. They both means the same way. Okay, so the first things that we have to do is we draw this cross and then these two lines. Right, there are a total of 9 places that 9 positions that we have to fill up. They are 1, 2, 3, 4, 5, 6, 7, 8, 9. And the first 3 positions that we filled up are this one, which is x squared, and then followed by positive 3, and followed by minus 4x. These terms are obtained from this. This is the x squared, this is the plus 3 that goes here, and this minus 4x goes here. So the next 2 positions that we filled up are this one. This is x and this is x. Why is it x and x? Is because these 2 terms you need to multiply them to get an x squared. So an x multiplied by an x, you have an x squared. The next 2 positions are this one. This is a 3 and this is 1. And again we have to multiply them. 3 multiplied by 1 is a 3. At this moment, do ignore all the signs that we have to input. Okay, we will only input the signs at the end. So the remaining 2 positions, this and this, are obtained by multiplying this term with this term. So x multiplied by 3, you will get 3x. So the other blank is x multiplied by 1 to get an x. So the difference between these 2 positions, between these 2 terms, you need to add them instead of multiplying, unlike these 2 positions. So let's see, 3x added to x is 4x. You don't get your negative 4x. So we have to change this, or we need to add the sign to make it a negative 4x. So this has to be minus 3, this has to be minus x. Minus 3x plus minus x is minus 4x. So this is correct. So now, since this is negative 3x, this 3 has to be negative. Since this is negative x, this has to be negative 1. So let's do an inspection again. Negative 3 multiplied by negative 1, you get positive 3. Yes, so this is the correct combination of terms. So when this expression being factorized, you will get x minus 3 and x minus 1. basically the factors are obtained from all these terms. These are your factors: x minus 3, x minus 1. Okay, so this is how we do the factorization of quadratic equations. Okay, we have done one example. Let me do another example, and this is a rather bigger number. Okay, we have a minus 21 and a plus 68 as the two numbers divided. We need to find their combination. So let's see what we can come up with. We draw the x again and these things. Now I'm not going to show the 9 different positions because we already know the different positions that has to be filled up. So let's fill up those 3 positions first. Plus 68 and minus 21x. There is only one way to get an x square, which is an x and an x. Okay, so we need to find what two combinations will give us a 68, and at the same time when we add those two numbers, we can get a 21. So let's list down all the different factors of 68. Let's go with 1 and 68, 2 and 34, 3, no, 4, 4 and 17, and yes, I think I found the factors. 4 and 17 can give me a 21. So I'm going to stop at this and let me input my 4 and 17. Again, I have ignored the signs and I'm going to get 4x and 17x. The way to get negative 21 is by having a negative 4 and negative 17. And that means I need to have a negative 4 here and a negative 17. Let's do a check. Minus 4 plus minus 17 is minus 21. So this is correct. Minus 4 multiplied by minus 17 is plus 68. And x times x is of course x squared. So yes, this is the correct factors. And these are my factors finally. X minus 4 and x minus 17. Done, factorize. Okay, here we have another example, and this is slightly or rather more complicated, where the coefficient of x squared is no longer 1, this time is 20. And let's see how I am going to solve this or rather factorize this equation. The first thing that I'm going to do is rearrange the terms in this manner. 20x squared minus 25x plus 5. Okay, and somehow I get to see that there's a common factor between 20, 25 and 5. So I'm going to factorize that first, and the common factor is 5. That leaves me with 4x squared minus 5x plus 1. So now it is easier to factorize this. It's no longer intimidating, right? So let's apply that steps again. The x and this thing, 4x squared minus 5x plus 1. So this is 4x squared. This is positive 1 and minus 5x. Let us try with 4x and x here, and a 1 and a 1, I get an x, I get a 4x. To get a minus 5x, this has to be minus, this has to be minus, so this has to be minus and this has to be minus. So let's do a check. Minus x plus minus 4x is minus 5x, so yes, this is correct. And minus 1 multiplied by minus 1 is positive 1, so this is correct. And 4x times x is indeed 4x squared. Yes, so all these three terms are satisfied by all these combination of numbers, so these are the correct factors: 4x minus 1 and x minus 1. Okay, 4x minus 1, 4x minus 1 and a x minus 1. So these are our factors. Okay, so guys, if you think this has benefited you, if you have understood this, or if you have a better understanding of how to do factorization of quadratic equations, please do share this with your friends, your relatives, classmates, or whoever, so that they will benefit from this as well. Yeah, so I hope to see you at my other lectures, and till then, go factorization.